Hi everyone. Today we're going to be talking about points, lines, and planes. The objective of today's lesson is simply to introduce you to some of the basic terms that we're going to be using this year and how to name them. So let's start with a few definitions. First, we have a point. A point is simply a location in space. In a picture, a point will be represented by a small dot. When we name a point, we simply name it using a capital letter. For example, if I were to have a rectangle, I might name the vertices of the rectangle, and when I name them, I would use a capital letter. This is a point on the rectangle. Now, if someone asked me to name this point right here, I would not use a symbol. I would just simply say, that's point A. Our next definition is a line. A line is a set of points that extends in opposite directions without end. In other words, a line goes forever. So when we're talking about a line, when we name it, we use a symbol with arrows on each end. When you name a line, above the name of the line, you're going to draw a symbol that looks like this. When you name a line, you can use any 2 points that are on the line, or if the line has a single lowercase letter, you may use that. For example, if I were to have a line that looked like this, and I could have several points named on the line. Notice I've given you 4 points, but if you wanted to name that line, you could pick any 2 points that you wanted and name the line that way. So for example, I might name this line A, B. I could also name this line CD, or maybe AD. I could even go backwards and name it line BA. It does not matter which 2 points I pick, because I actually am showing by these arrows that it goes through point A and through point B, and it keeps going. So it indicates that it's everything. Sometimes you'll also see a little letter at the end of a line, like maybe they'll have a little M here. And then if I wanted to name this line, I could simply say this is line M. And that would be another way to name that line. Our next definition is collinear points. We know what a point is, and now we need to know co. Co means on the same, and linear, we learned in algebra, refers to a line. So collinear points are simply points that lie on the same line. For example, in my last picture, A, B, C, and D were all collinear points because they were on the same line. A plane is a flat surface with no thickness that extends forever in all directions. Think about a piece of paper that you could not see the end to. It never ends. Another example, think about like the ceiling of a building. You don't see the entire ceiling. If you're standing in the classroom, the ceiling extends beyond the classroom. Imagine that that were to go on forever. When we name a plane, we can name it by a single capital letter or by at least 3 points in the plane that are not collinear, or in other words, 3 points that are not all on the same line. For example, in a two-dimensional drawing, a plane is simply going to be represented by something like a parallelogram or something like that, because you can't actually draw forever. And if I had some points drawn on this plane, I could name the plane using any 3 points as long as they weren't all lined up together. So I could name this plane ABC. Or I could name it plane ABD. or plane CBD. Sometimes there will be a capital letter down in the corner of a plane, like maybe a V, and then I could simply call it plane V. But that's the only way that I can use a single letter. Otherwise, I have to use at least 3 letters from the points on the plane. And my last definition, I'm going to erase what I've written here so that I'm not above my last definition. Coplanar points, just like collinear points, co means on the same plane. So coplanar points are any points that lie on the same plane. Okay, so let's look at a picture and use what we've just learned to name some of these things. A says name the plane shown. The plane is this flat surface right here. So we learned on the last slide that we can name a plane using any 3 points as long as they're not all on the same line. I might name this plane R, Q, V. R, Q, and V are on the plane, and not all 3 of them line up. It's okay that R and Q are on the same line, as long as V is not. Another example, maybe I could call this plane Q, S, V. The P in the corner can be used to name the plane. I can call this plane P. Notice P does not represent a point in this picture, so I would not name it plane PRQ. R and Q are points, P is not. I cannot say plane TQS because T is not on the plane. If I look at this picture, RQS is lying on the plane, but this line is piercing the plane. It's like it's stabbing it. It's going through from the top down through the bottom. Same thing with the N. The N is not on the plane, so it cannot be used to name the plane. Okay, let's look at letter B. Letter B says to name line RS 3 other ways. So RS, notice point Q is also on that line. So maybe a different way would be to name it line RQ. I could also turn RS around and name it line SR. Another possibility would be line QS or line QR. But also remember we learned on the last slide that it is okay if there's a small letter there to name this using that letter. That's just a cursive L, so that's line L. That would be another way to write that. Okay, letter C, name 3 collinear points. Remember, co means on the same line. So name any 3 points that are all on the same line. For example, here we might say R, Q, and S. Notice again, these are points, so I don't use any symbol to name them. Can you think of 3 other points that would be on the same line besides R, Q, and S? And our last one on here, name 4 coplanar points. In other words, any 4 points that are on the same plane. An example here would be R, Q, S, and V. Even though V does not line up with R, Q, and S, it is on the same flat surface. So R, Q, S, and V are coplanar. Let's look at another definition. A postulate. We're going to be using lots of postulates in geometry this year. A postulate is simply an accepted statement of fact. It's something that we accept to be true. A theorem is a true statement that can be proven. So both a postulate and a theorem are accepted as true. The difference is we can prove that a theorem is true, while a postulate we simply accept that it is true. We have 4 different postulates in this lesson that we're going to talk about. Postulate 1-1 says, through any 2 points, there is exactly one line. Basically, what that means is if I were to draw 2 points, there's only one line that you can draw through those 2 points. If you were to come up and draw a line through those points, and then I asked somebody else to draw a line through those same 2 points, they couldn't draw a different line. It would be exactly the same. Postulate 1-2. If 2 lines intersect, then they intersect in exactly 1 point. If you have 2 distinct lines and they're going to cross each other, you can't make them cross twice. I can draw a line that crosses, but since a line does not change direction once it's crossed at one time, it can't cross again. So basically, if you draw 2 lines, they can only intersect one time. This is kind of the hard one to understand to begin with. This one says if 2 planes intersect, then they intersect in exactly one line. What that means is if you have 2 flat surfaces that are slicing through each other, where they cross, it will create a line. It's hard to envision on a drawing because notice our planes in a drawing don't actually go forever. But if you could imagine that this actually went forever and this yellow box also went forever, then where they intersected would continue. And so 2 planes always intersect to form a line. Think about the wall of a room and the ceiling of a room. They intersect across the entire top of the room, and if those were to continue, that would keep going, so that would create a line. So we're going to look at a couple of pictures here. It says, what is the intersection of plane HEF and plane CBF? When I look at plane HEF, I notice that those are 3 points on the bottom side of this box. So HEFG would be another way to name that. So I'm talking about this plane and plane CBF. Notice CBF is the side of the box and it also includes G. So we had HEF, which also included G, and CBF, which also included G. There's a couple of different ways we could get our answer here. If I look, I can actually see that the box folds at FG. I can also look at the names and notice that F and G are points on both sides of the box. So they intersect at FG. We call that line FG because even though this looks like a segment, if this was truly a plane, it would go forever, which means the intersection would also go forever and become a line. So we're going to try another one just like that. So let's erase our drawing and start over again. We have plane DHG. So plane DHG looks like the back of the box, and it also includes C. Then we have plane DAB, so D, A, B, and that also includes C. That's the top of the box. So if I look at my picture, I have the top of the box and the back of the box, and they fold at DC. I can also tell by looking at the names, they both include D and C. So the intersection is line DC. Now we're going to look at one more example, just like the last two. It says, what is the intersection of planes ABC and HEF? So if we look at our picture again, ABC is again the top of the box, and that's ABCD. So ABCD is the top of the box. And then we have HEF, And if we look, H, E, F, that would also include G if we went around. That would be the bottom of the box. Notice the top of the box and the bottom of the box don't actually intersect. These are what we call parallel planes. So there is no intersection. Notice that if we had looked at the letters, the top one was A, B, C, D. The bottom one would be H, E, F, G. There is no intersection. They don't share any common letters. Okay, for our last example here, we're going to go backwards. On each of the other three, I gave you the two planes and asked you to find the intersection. So now, I'm asking you to name the two planes that intersect at line BF. In other words, what two sides of the box include BF? So if I'm looking at this picture, the front of the box has BF. B, F, E, and A. If I want, I can pick just three of those letters, but it is okay to name a plane with more than three. So if I want, I can even say plane BF, EA. And line BF is also on the side of this box, so BFGC would be my other answer. So plane BFGC. Notice that for both of them, they include B and F. Our last postulate for today. Through any three non-collinear points, there is exactly one plane. Remember, collinear means on the same line, so non-collinear means not on the same line. So if we have 3 points and they are not all on the same line, there is only one flat surface that will include all 3 points. You can't have 2 different planes going different directions and have all 3 points be on both of them. So we've got 2 more examples together to finish up our lesson today. For the first one, it simply says shade the plane that contains H, G, and F. We've kind of already done this on a couple of the other slides. We have H, G, F, and E. So really, I just want to shade the bottom of the box. I'm going to use a different color so we can keep track of what we've done here. So shade the plane that contains D, A, and F. So there's D, A, F. The natural tendency for many people is to say, well, wait, there's no plane that contains all 3 of those. But remember, our last postulate said that through any 3 non-collinear points, there is always one plane that you can draw. The plane is not shown in this picture, but because there's 3 points, I know one exists. I could draw a flat surface connecting these 4 points. It's not drawn in the picture, but there could be a plane that went diagonally across the box that would connect points D, A, and F with point G. So this is my answer to the last one. So this is the end of today's lesson. Thank you for watching, and I will see you in class.